Hello students, welcome back to my YouTube channel. In this video, I am going to discuss about velocity in two dimensions. First, we will discuss about the average velocity, then I will discuss instantaneous velocity. Okay. What is average velocity? Average velocity is the velocity in a particular interval of time. Okay. So, average velocity is equal to the displacement in that particular interval divided by that time. Okay. So, this is the average velocity. So, if you consider a particle is moving in a plane in a curve path, this is the y and this is the x-axis. Okay. The particle is moves in like this. So, this is the initial point, that is the P1 is the position of the body at t1 instant. Okay, the position vector of P1 is R1. Okay, after t2 interval, the bodies are in the position P2. Okay, the position vector of the P2, the position vector of the P2 is R2 vector. Okay, then what about the displacement? Displacement is the difference between final position vector and initial position vector. So, in this I consider delta R is a displacement. Okay, that is the difference between the final position vector. What is the final position vector? That is R2 minus the initial position vector, that is R1. Okay, then what is average velocity? Average velocity is equal to displacement divided by time, that is delta R divided by time. What is the time? That is t2 minus t1. Okay, this t2 minus t1 I can consider as delta t. So V average is equal to delta R divided by delta t. Okay, here the direction of V average is similar to the direction of delta R. Delta R is the displacement. What is the displacement direction? Displacement direction means a straight line from initial to final position. So this is the delta R direction. So the same direction, the average velocity also. Okay, then if this point P1 is x1 comma y1 and this point P2 is x2 comma y2. Okay, then what about the delta R? The delta R is equal to R2 minus R1. So we need to know what is R2. R2 is the final point position vector, that is x2i plus y2j minus. What is R1 vector? R1 vector is the position vector of the first one. Okay, so that is x1i plus y1j. Okay, from this delta you will get as x2 minus x1i plus y2 minus y1j. Okay, so this I am taking as delta x and this I am taking as delta y. So delta R is equal to delta xi plus delta yj. Okay, then what about the V average? V average is equal to delta R divided by delta t. So delta x divided by delta ti plus delta y divided by delta tj. Okay, that means what is the displacement in the x-axis divided by time plus what is the displacement in the y-axis divided by time, that is Vxi plus Vyj. Okay, Vx is the x component of the average velocity and Vy is the y component of the average velocity. Okay, clear? So this is about the average velocity. Okay, and the direction of the average velocity is similar to the direction of the displacement. Okay, now we will see instantaneous velocity. instantaneous velocity. The instantaneous velocity means velocity at a particular instant. That means if a car is moving in around 10 a.m., exactly at 10 a.m., what is the instantaneous velocity? Okay, that instant, what is the velocity? Okay, so if you consider about an average velocity, that is V average is equal to what? Delta R divided by delta T. Okay, if this delta T, that is the time difference, is very smaller, what you will get? The velocity become at a particular instant. The time difference is decreases and it will be very smaller. The average velocity become the instantaneous velocity. So we can consider the instantaneous velocity is the limiting value of average velocity. That means the instantaneous velocity we can write it as limit as delta t tends to 0, delta r divided by delta t. Okay, what about this? This is equal to derivative of r with respect to time. Okay, this is the instantaneous velocity. Okay, then if we will consider a motion in a plane, this is a y-axis and this is x-axis. The particle is moving in a curved path. Okay, this is the initial position. This P1 is the position at T1 instant and the position vector is R1. Okay, and this is the P2 is the position vector of, P2 is a point and R2 is a position vector. Okay, then if this P1 point is x1 comma y1 and this P2 point is x2 comma y2. Okay, in between, what about the instantaneous velocity we have to see. Okay, so for this I am going to consider delta r. Okay, delta r is equal to r2 vector minus r1 vector. Okay, r2 vector is equal to x2i plus y2j minus of r1 vector is x1i plus y1j. From this you will get it as x2 minus x1i plus y2 minus y1j. Okay, then this we can write it as delta xi plus delta yj. This is delta r. Okay, then we will substitute this in here. So this P1 instant is T1. So the delta T is equal to, and the P2 instant is T2. So the delta T is equal to T2 minus T1. Okay. Then now we will substitute it here. You will get as V is equal to limit as delta T tends to 0, delta x divided by delta T I plus limit as delta y divided by delta t. Okay, what about this? This is the x component of the velocity. That is V is equal to Vxi plus Vyj. Or we can write it here itself like this. We can write dx divided by dt I plus dy divided by dt j. Now we can write that is V is equal to, this is the x component. Okay, derivative of the x component divided by time plus derivative of the y component. Okay, so Vxi plus Vyj we will get. Okay, this. What about the magnitude of the instantaneous velocity? Magnitude of the instantaneous velocity, that is V is equal to what you will get? Square root of Vx square plus Vy square. Okay, this is the magnitude of the instantaneous velocity. Then we want to see the direction. So here, what about the direction of the velocity? Here the direction of the velocity, that is average velocity direction, is similar to the displacement direction and is a straight line from initial to final point. This is the velocity direction here. For an instantaneous velocity, this time difference is very small. So we will take that, guys. Okay, if the time decreases, that is the time difference decreases, what will be happen? The same path P1 and this is P, and consider as another point, that is P3, that is little bit closer to the P1. So this position vector is R1, that is the P1 position vector is R1 and the P3 position vector is R. Okay, then what about the velocity direction? The velocity direction is a straight line from P1 to P3. Okay, this is about here. So now you see it is coming a little bit closer to the path. Okay, next. If again the time difference decreases, so this is y and this is x, this is the path. This is P1. P1 position vector is R1 and considering a point that is P4. P4 is very closer to the P1, that is position vector is R4. Okay, now you see what about the velocity direction? Velocity direction is just you draw a straight line from P1 to P4. This is the velocity direction. Okay, so now you see the velocity direction is just over the path. So if you decreases the time difference, you can see that the velocity direction is just a tangent. This is the point P1 and its position vector is R1. Okay, then the velocity, that is the instantaneous velocity at this point, is just you draw a tangent. Okay, this tangent gives the instantaneous velocity at this point. Okay, so if any path, the instantaneous velocity at the point is just you draw a tangent. Okay, that means I am consider a path like this, like this. You see that in this point the velocity direction is like this. Here the velocity, instantaneous velocity direction is like this. Okay, here the instantaneous velocity direction is like this. Okay, this way you can find out the instantaneous velocity direction in a particular path. Okay, this is about the velocity in 2 dimensions.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like.